1. What is a virtual network, VNet, in the cloud? A virtual network, VNet, is a logically isolated section within a cloud provider's infrastructure, allowing users to securely run and manage their resources like virtual machines, databases, containers, and applications. Think of it as a private network built in the cloud that mimics a traditional on-premises network. VNets provide complete control over IP address blocks, DNS settings, security policies, and route tables. It ensures that your services communicate with each other safely within the cloud. Services in a VNet can also connect to on-premises infrastructure using VPNs or ExpressRoute in Azure or Direct Connect in AWS. 2. Why do we need virtual networks in cloud environments? Cloud platforms are inherently shared environments. Without a virtual network, your resources could be exposed to the internet or other tenants, which is a major security risk. VNets provide isolation and allow you to segment applications across different subnets. They also allow for secure communication, advanced routing, access control, and integration with on-premises networks. For enterprises, VNets offer the flexibility to replicate their existing network architecture in the cloud and maintain compliance and security standards. Essentially, they bring the structure and control of a private data center into a cloud-based model. 3. What components make up a virtual network? A virtual network consists of several key components. First, there's the address space, which defines the range of IPs, CIDR block, available in the network. Then you have subnets, which divide the VNet into logical segments. Network security groups, NSGs, act as firewalls controlling inbound and outbound traffic. Route tables define how traffic flows between subnets and external networks. DNS settings help in internal name resolution. For hybrid connectivity, components like VPN gateways, peering, and ExpressRoute, Direct Connect enable secure data transfer between cloud and on-premises environments. 4. What is subnetting and why is it important in VNets? Subnetting is the process of dividing a large network, like a VNet, into smaller, manageable segments called subnets. It helps in organizing resources, enhancing security, and managing traffic flow efficiently. Each subnet has its own IP range that falls within the VNet's address space. For example, if your VNet uses 10.0.0.0/16, you could create subnets like 10.0.1.0/24, 10.0.2.0/24. This segmentation allows you to isolate workloads, separating databases from web servers, apply different security rules, and control traffic between them. Subnetting is crucial for scaling and maintaining organized infrastructure. 5. How does communication work between subnets in a VNet? By default, all subnets within the same virtual network can communicate with each other without any additional configuration. This allows resources like VMs in different subnets to interact using their private IP addresses. However, you can restrict or allow traffic between subnets using network security groups, NSGs, by applying specific rules. For example, you might want to block traffic from a web tier subnet to a database tier subnet except for SQL port 1433. This fine-grained control ensures secure communication and adherence to a layered network architecture model, such as web, app, and data layers. 6. What is CIDR and how is it used in VNets? CIDR stands for Classless Inter-Domain Routing and is used to allocate IP address ranges. In the context of VNets, CIDR notation defines the IP range for the entire network and its subnets. A CIDR block like 10.0.0.0/16 means that the VNet can contain 65,536 IP addresses. When creating subnets, smaller CIDR blocks like 24, 256 IPs, or 28, 16 IPs, can be used. Choosing the right CIDR size is essential to avoid wasting IPs or running out of addresses. CIDR also plays a critical role in routing and defining network boundaries in the cloud. 7. What are common issues that arise in virtual networks? Some common issues include IP address conflicts, misconfigured subnet ranges, missing or overly restrictive NSG rules, and routing errors. Additionally, peering misconfigurations or incorrect DNS settings can break connectivity between services. For example, if a subnet is too small, you might run out of IP addresses, preventing new VMs from being deployed. Or, if NSG rules block important ports like 443, HTTPS, applications won't be accessible. Also, forgetting to update route tables or DNS settings when connecting to new networks often causes service failures. Identifying and resolving these issues is key to maintaining a stable network.